In this video, we're going to look at a couple of slightly more complicated examples. They're still not the most difficult that you're going to see, but they are slightly more complicated. So try to stay with me. Okay, so for the first example, again, just like the simpler ones in the last video, this is an exponential problem combined with a multiplication problem. So, as always, we're going to do exponents before multiplication. So, we're going to say the rule for raising to a power, raising a product to a power, says that each factor gets the power. So I'm going to give 3 the power, x to the negative 4 the power, y squared the power, and z to the negative 6 the power of 3. Now that 3y to the negative third is just going to hang around because he doesn't have an exponent to give to each factor. Alright, so I'm going to simplify a little bit. 3 cubed is 27. When you raise the power to a power, you multiply the power, so that would be x to the negative 12. When you raise the power to a power, you multiply the powers. 2 times 3 is 6. And z to the negative 18. Now that is times 3y to the negative 3. Now I don't have any parentheses left, so I'm one step closer to being simplified. And I'm going to collect like bases because I have 2 base y's, so I know that's not going to be my simplest form. So I'm going to put the 27 and the 3 together. The x doesn't have another like base. I'm going to put my y to the 6th times y to the negative 3 together. And then again, z doesn't have any like base, so he's by himself. Okay, so now to simplify that, 27 times 3 is 81. When you multiply with a common base, you add your exponents. Now, I have a good many students who want to stop right here and say this is finished, but it's not because I have negative exponents. So what I'm going to do is go down one more time. Tell you I've got 81. Y was to the positive third power. X was to the negative 12, so I'm going to move him into the denominator and make that a positive 12. And z was to the negative 18, so I'm moving him to the denominator and making it a positive 18. I have no parentheses. I have each variable showing up only one time. And I have no negative exponents. So this is my final answer. And now for a division problem, raised to a negative exponent. Again, I can do this numerous ways, but most students find it a little bit simpler if I will simplify inside parentheses first, which is kind of what the order of operations tells me to do. I do not have an exponent to go with my 2, so he's fine where he is, and I am going to express my 1 just that those of you who might get a little lost, if everything disappears, it's there. Okay, for the x. The exponent on the x is greater in the numerator. So I'm going to come down here and put my x in the numerator. And then I'm going to subtract, because when you divide with a common base, you subtract your exponents. 3 minus negative 3 is a positive 6. My y exponent is greater in the numerator, so I'm going to put the y's in the numerator. And I'm going to subtract their exponents. 4 minus negative 4 is positive 8. Well, maybe. Okay, then z is also greater in the numerator, the exponent is, so I'm going to put z in the numerator. And I'm going to subtract their exponents. 5 minus negative 5 is negative 10. Positive 10, excuse me. That is raised to the negative 2 power, though. Okay, so I do have it simplified inside, and I could do this all at once if you wanted me to, but I'm going to break it down again into 2 steps for those who need it. So to take care of the negative, I'm going to invert the fraction, that is, flip it over, find the reciprocal, however you want to say it. I am going to leave the 1 off this time because I know the x, y, and z are all 3 there. And that takes care of the negative, leaving me with a positive 2. So, how do you simplify an exponent on a quotient? You give both the dividend and the divisor the exponent. So, for the dividend, that's 2 squared. Before the divisor, I'll write it out in an extra step. I kind of don't usually, but I'm going to. I'm going to give each factor, because see, it's a multiplication problem in the divisor, and so I'm going to give each factor the power of 2, if I can. And when you raise a power to a power, you multiply the powers. 6 times 2 is 12. 8 times 2 is 16. And 10 times 2 is 20. Final answer. No parentheses, no negative exponents, nothing that gives me any problems. Good luck. Work several of these before you go on to the more difficult.